Hello everyone. So today we are going to solve another dynamic programming problem, which is the combination sum fourth problem from Leetcode. It is also a medium level problem. So let's just directly jump into the problem statement. So it says, given an array of distinct integers nums and a target integer target, return the number of possible combinations that add up to the target. Also, they have said that the test cases are generated so that the answer can fit in a 32-bit integer. So we don't have to worry about any overflows or anything. The answer can be stored in an integer variable. So going by the example, they have given the target as 4 and the numbers that we have with us are 1, 2 and 3 and the output expected is 7. The explanation is also provided. So 4 times 1 or 2 times 1, then 2, 1, 2 and 1, 1, 3, 2, 1, 1, 2, 2, 3, 1. So all of these will always add up to 4. Another example is given in which your target is 3, but the numbers that you have with ourselves is only 9. So basically, there is no way you can generate 3 by using a 9. So which is pretty straightforward. So the output expected is 0. So let's try to see how we will go about solving this thing. So let's jump to the intuition and try to think. If let's say we had to generate 4, my options are either I can pick 1, or I can pick 2, or I can pick 3. But I don't know what I should pick. So basically, what I will do, I will just try out with all the choices that I have and then further try to solve it. So what will happen is we initially had to solve for 4. So let's say that I have picked 1. Then our target remaining will be 3. Other choice would have been I could have picked 2, then my remaining target would have been 2, and finally I could have picked 3 and my target would have been 1. Then now let's try to expand 3. So for 3, what we can do, we can pick 1, then we will need to find out total number of ways for 2. I could have picked 2 as well, then I would need to find out for 1, and I could have picked 3 also, then for 0. So you can also see that this 2 is getting repeated again. It is getting solved again, and then finally if I go, so that is why I'm not expanding 2 here. So if I go to this part, for 1 we have only one choice. You can only pick 1, then target will become 0. We cannot pick 2 because then target will become -1, which is not possible. And I also cannot pick 3 because then the target will become -2, so that is also wrong. So only this thing is valid. And if I expand this one, then for 2 I can pick 1, or I can pick 2, then it will become 0. So ultimately, basically, when this thing becomes whenever this thing will become, the target will become 0, the answer will be 1. That this particular one branch that we have will constitute to one way that the target can be generated, this thing, which is 1, 1, and 2. Or this will again become 0. So it will be 1, 1, 1, 1. So this is how the combinations are getting generated. Similarly, if I expand for all the other branches, you will see the pattern. So here, the basic thing which is clear is that we have a target number and we have the possibilities, the choices that I have. What I will do, I will basically just try picking each and every one of the coin, and I will try to see how many ways there are for the remaining amount. And once I add all of them up, then that will be my answer. So basically, the answer for 4 would simply be, if I write it in a function format, so f of 4 will simply be equal to, if I pick 1, then f of 3, then I will pick 2, then it will become f of 2, then I will pick 3, then it will become 1. So you can say that, like, clearly we can build this up in a bottom up manner, and ultimately, as we saw in the base case, f of 0 will be 1. So basically, this is our base case, that whenever our target is 0, there is only one way that I can generate it with. So let's try to dry run this, and then things will become even more clear. So we will initialize a DP array with size. And this will be an integer DP array in our case of size target plus 1. So why target plus 1? Because we need to store initialize it, like our base case is the 0 target. So basically let's try to fill this up for this current example only. So for 0 there will be 0, 1, 2, 3, and 4. So I am writing the indices here. So these are basically our targets. Initially everything is 0 here, only this value will be 1. So let's try to see what will happen when our I is 1. Target 1, for target 1 we can choose number 1. So for that it will be dp of 0 plus, can I pick number 2? No, because then it will make our target negative, and I also cannot pick 3 because it will again make our target negative. So this will only be dp of 0, which is dp of 0 is 1. So here we will put 1. Now let's try to see for I is equal to 2. For 2, I can pick 1. So it will be dp of 1. Then can I pick 2? Yes, I can pick. So it will become dp of 0. Then can I pick 3? No, because then our target will become minus 1. So this is the only two options that we have. So dp of 1 is 1 and dp of 0 is also 1. So this will be 2. Now dp of 2 becomes 2. Now let's go to I is equal to 3. For I is equal to 3, I can initially pick 1. So it will become dp of 2 plus, can I pick 2? Yes, I can pick 2. Then it will become dp of 1. And lastly, can I pick 3? Yes, I can also pick 3. So this will become dp of 0. Ultimately, it will become 2 plus 1, which is 4. So here we will have 4. Okay, so far we have filled the table up to I is equal to 3. Let's try to see what will happen for I is equal to 4. For I is equal to 4, I can pick 1. So this will be dp of 3 plus I can pick 2. It will be dp of 2. And I can also pick the value 3. This will be dp of 1. Since like nothing is making the target negative, I can pick all those three values. So it will be 4 plus 2 plus 1, which is 7. And then in the end, we will just simply return dp of target. So if we check in the example as well, the expected answer for target 4 is 7. And this is how your dp table will look like at the very end. So it's pretty straightforward. Now let's jump into the code. So starting with the code, we will first of all initialize our dp array, which will be a simple 1D array of size target plus 1, and we will initialize dp of 0 with 1. That's it. Rest of the values are initially 0, and I will start that I from 1. I is less than equal to target I plus plus. Here we will fill the table somehow, and at the very end we will simply return dp of target. Cool. So what do we need to do for each current target that I'm considering, which is the value of I need to go to each of the coin. So let's go to a coin which is given to us in the nums array, nums dot length j plus plus. Now I just basically need to check the current number that I am picking. It should always be less than or equal to I, because it can't be the case that the target that you are trying to calculate is 5 and the number you are picking is 10. That is not allowed, because like I mean, it should always be less than or equal to the target. So if that is the case, what we will do, we will add we will add the value of, I will pick the current number, and whichever is the remaining amount, I will add it to dp of I, and that's it. This is the only condition that we need to basically ensure that we are not running into negative indices or something that is not possible. After that, this should be fine. Let's just try to run this. Okay, so basic cases are getting accepted. Let's try to submit this. Cool. So it works fine. All the cases are now accepted. So that's it. If you have any doubts or questions, please leave them in the comment box, and we will see you in the next video.